Hey folks, so this is a whole different view. This is the other side of the garage. The bench is back there. The reason that you're seeing this side is because I'm working on a bigger project. I took some inspiration from Flight Test and their new helicarrier. It is huge. I wanted to build my own. So I went out and I got some supplies, and I kind of made a video on this already, but it turned out crap because it was real late at night and it just was horrible. So you've got me about halfway through cutting this thing out, and I'm going to show you all exactly what I'm doing here. But what I ended up doing is going out, because I work in construction, I'm around this stuff a lot. This is a blue polystyrene insulation. This stuff is 2 inches thick, and I got this at my local hardware store, Lowe's to be exact. And a 4x8 sheet of this stuff I think cost me about 30 some odd bucks. So the helicarrier that I'm building, because I'm using this poly extruded foam, requires the use of a hot wire cutter, which I didn't have, so I had to end up building one. And I'm going to show you all that stuff. But let me show you the basics of what I got here. So this is the basic outline of the helicarrier itself. Let me just kind of move this sucker out of the way for now. I'll get to that in just a few minutes. Big ass ruler, which is really nice to have, by the way, when you're making these really long lines. So this is the basic outline of it here, and as you can tell, it's big, but it's lightweight. Right now, the last measurement I took on this thing before I started cutting some more stuff off, when I had like this section and this down here, was about 2.5 pounds. So we're definitely taking some meat off of this thing since then. But basically, this sucker is, well, there's 48, and I think that was the hot wire foam cutter falling off the table, by the way. This sucker's about 50 inches long. And to put it in terms that you guys understand, so the Blade 350QX diagonally from here to here is 350 millimeters. So this being also having metric on it, we're going to go from the center of 1 to the center of 3, so diagonally across it, and we're looking at 960 millimeters. Across, well, in inches, you're looking at just a hair under 38 inches diagonally. And across from motor to motor is 27. So, definitely big. But what I'm using to power it, because this thing is so lightweight, I'm actually just using the Turnigy Multi-Star motor, the replacements for the Blade 350QX that I ordered, used like once. I was happy with them, they performed fine. I just didn't end up using them on my 350. And then I've got 8-inch by, I think these are like 4.6 or 4.7 T-props from hobbyking.com. So what I'm using to cut this out with, get it up off the floor, is this here hot wire foam cutter. And basically the principle behind it is you apply a voltage to the wire heats up because of the resistance in the wire, heats up enough to slice through the foam. beforehand was I had my battery, and y'all recognize this if you're 350QX flyers. This is the 2200 milliamp stock 350QX battery. And I had that just hooked up to said wire that I've got coming off of this. And it worked. The problem with it was this would heat up to red hot, degrade the wire over a short period of time, and it would snap. And so I was doing, before I got the parts that I have to make this work properly, I was just doing as fast as I could, take as much meat off to get it down to somewhere around here till my parts came in and I could use this properly. So what I ended up doing, I took some more inspiration from Flight Test. David Wendestall, when he was doing the vegan, showing you how to cut out the hot wire, basically cutting out this stuff for doing the body for the vegan. He has a brushed, not a brushless, ESC, and this is a Turnigy 20 amp ESC, and then he has a servo tester hooked up to it. Basically, this is just a potentiometer that allows you to adjust to regulate the voltage being applied to the hot wire. Both of these I got from Hobby King. I think this was around, $9. This here was about $7. I'll put the links in the description below. They just came in today, and I'm quite happy with it. So basically the way I've got it hooked up is on one side of this you have the output, and you have two jumpers in here, and what this is, I don't know how well you can see that. Let's see if I can get that to focus. On one side you've got the brake, and on the other side you've got your battery type. So one is NiCad, one is LiPo, and when it comes to you, it's actually like that for NiCad, or is it NiCad? NiCad, nickel metal hydride, whatever you got. So you just got to take that there jumper, pull it out to select LiPo. This side of it, of course, you've got your servo lead and going out to the batteries. And to hook this up, it's really simple. You just plug it into one of the outputs on the servo tester. When you start it up, plug it into the battery for the first time. You want to make sure that your dial is all the way 0. That's going to initialize the ESC just the same as if it was hooked up to a receiver. When you hook it up, you're going to get a long beep. Everything's ready to go. Then you can just go ahead and dial up your voltage. Now what I've found, because I'm not actually using nichrome wire. I'm using this here stainless steel wire that I picked up at my local Harbor Freight. This roll is 25 feet of, I think it's 0.041 stainless steel wire. Really all this is safety wire for mechanics. So you have a nut or a bolt that has a little hole in the bolt. You don't want that nut backing off. You can just take some of this stuff, wrap it through. Really, that's all it is. So since I'm not using nichrome, I wanted to be able to finally adjust the voltage. And what I've found with this, and it actually works really well, as soon as you start applying enough voltage to the wire, right about where it starts getting within the cutting temperature, it starts to whine at you. So I'm just going to show you real quick. So that's all the way down. I'm going to take my battery. There's the long beep. Now it's funny because the ESC doesn't beep. I actually hear the beep from the wire. It's going out and reverberating through the wire, and that's where I'm getting my tone from. So let me grab a scrap piece here real quick. So this is just a scrap piece of foam. one that actually I just recently cut off. And I'm just going to go ahead and adjust up the voltage right about to where it starts beeping there. And as soon as it gets warm enough, there you go. There's your hot wire foam cutter. So let me go back over here, and I'm just going to show you real quick. I mean, this is easy. This is one of the easiest. Make sure I'm not around the table there. This is one of the easiest projects that I've done as far as the manufacturing of the body or frame of the multi-rotor. Okay, so we've got everything here. I'm just going to turn my voltage up. Got the beep. I'm going to wait a couple seconds. There we go. And I've got it on the line that I want to cut. And I'm not going too fast. I'm just kind of letting... And you hear that double beep, and that means we've got a problem. And unfortunately, I'm kind of stuck in here. So what I'm going to do is unplug it, reinitialize it, and I have not run into this problem yet. Okay. Well, I was really all set to show you all exactly how well this thing works. And it's kind of being a cunt. I have no idea why. But as far as cutting the foam out, this was really easy. Let's see if I can't fiddle with this here for just a quick second and see if we can't get it to come back to life. There's my long tone. Well, I'm going to have to go and look at the damn user manual, which I hate doing, in order to figure out why the ESC is giving me some goofy tones. But you guys get the general gist of what we're doing here. Oh, and a quick side note. So this is what I'm actually using to reinforce everything, and it looks kind of flimsy, and that's because, well, it is. It's a long length of wood, but really this is just kind of a molding, I guess. It's about 3/16 of an inch thick by 3/4 wide. And what we're really going to do is we're just going to stretch this across here like so for support. And then we're going to have one going down the keel as well. So you kind of get the general gist of how everything's going to go together. And these little sanding pads, when you cut the hot wire, you get these here little threads come off of it. So if you take your sanding sponge really quick over it, it makes a nice, getting frame here, it makes a really nice smooth edge. So this is kind of a quick update, and as soon as I get this thing figured out, I'm going to go ahead and get the rest of that cut out. And once we do, we're going to start putting the rest of the guts inside of it. I'm thinking about real quick, let me grab this and show you what we're going to be using for the guts on this, for the brains. We're actually going to be using 3D Robotics PixHawk system. Really, because what my intention with this is, because it is a smaller because it is a smaller version helicarrier, we're going to be taking off and landing the 350 Nano QX, or not the 350 Nano QX, that'd be a hell of a big Nano. The Nano QX from Blade, and probably up to as big as the 200 SRX helicopter. So for takeoff, it's not too big of a deal, you know, if it's moving and all that stuff. But for landing, I'd like to have a stable platform with which to land everything on. So with the PixHawk system, being able to kick it into loiter mode, since I've already got the thing laying around, I might as well use it. Kick it into loiter mode, so it's just going to sit there and hover. We can land the aircraft on it and bring it back home. I hope you all enjoyed the update, or the first showing of the, well, it's going to be the 960 helicarrier. Stay tuned for more, because this thing is going to be badass when it's done, as soon as I can figure out why the hot wire is not doing what it needs to be doing right now. But we'll definitely keep you guys updated. Have a good night. Okay, so just a quick addendum to the last video. I figured it out. The reason why the hot wire quit working, battery was dead. So we've got a new battery on here real quick, and I'm going to show you guys just real quick how easy this is to cut out your hot wire. That's in frame. Okay, we're good to go. So I'm going to turn the servo tester up. We're going to power it up. We got our humming of the wire, which is, I figured out, is just about where we want to be for the cutting. And so we're going to make sure the table's not underneath there. And we're going to go ahead and start bringing that into where we want to cut. And we're not really pulling, we're just kind of letting the hot wire do the work. You know, I'm guiding it, but we're not going to really put a whole lot of pressure on the hot wire. And we hit that joint, and we're going to pull back. Just follow the lines. This isn't the most thrilling, most spectacular but it is the cleanest and most efficient way to cut this stuff. It doesn't leave a big, huge mess. And avoid the smoke. I'm a smoker, and this shit's just kind of really nasty. And I'm just going to pull out here, right there, shut the power off. And that's it. That's how quick and easy it is to run the hot wire foam cutter. And you can see right there, it's just a nice clean edge. I'll go ahead, grab the sanding block, couple swipes over it, and she's done. Alright folks, thanks again for watching. Well, I'm going to get the rest of this cut out, and we're going to start putting the hardware in it. More videos on this to come.